Professor Belfrost's science class is back.
Hi, welcome back to this channel. And today we'll again discuss another concepts related to science. So here's the science tutorial for you today. Are you ready? Let's continue playing this video. Okay, welcome back. So this is the seventh video on the list of exam problem discussion. As usual, I've prepared one physics problem, one chemistry problem, and one mathematics problem. Let's start from mathematics problem. Okay. Yeah, this one. Let X be a set with exactly 5 elements and Y be a set with exactly 7 elements. That if alpha is the number of one-to-one function from X to Y and beta is the number of one-to functions from Y to X, then the value of 1 by 5 factorial beta minus alpha is. Okay, so we have two terms, yeah, related to functions in mathematics. So first one is one-to-one function. This is one-to-one function, okay, injective, okay, and this is onto function, surjective function. Can you see the difference? I think yes. Okay, one-to-one, it means that with one element of x, it can only be paired with one element of y. Okay, and no repetition. But for onto function, okay, there may be two x, I mean the domain that's mapped to a certain uh, range element, okay, the same range element. So here we see that nx equals 5 and ny equals 7. So number of one function actually is easy. It's just combinatorial 7 5 times 5 factorial, because there can be 5 combination of position. Okay, and how about beta? Okay, actually we have the formula here I want to show you. Okay, so number of possible function is n m, injective is this. Okay, you can see this is a combinatorial shown above. For surjective, you use this to solve this, or yeah, you may follow this. Okay, but actually it means the same thing, okay, as you solve with this formula. Okay, this is a beta, this is from the book, this is the one that I solved. Okay, so you can get the answer that beta minus alpha divided by 5 factorial is about 119. Okay, now second question, physics. Consider hydrogen like ionized atom with atomic number Z with a single electron, and the emission spectrum of this atom that the photon emitted in the n equals 2 to n equals 1 transition has energy 74.8 electron volts higher than the photon emitted in the n equals 3 to n equals 2 transition. The initiation energy of the hydrogen atom is 30.6 electron volts, and the value of Z is. Yeah, the first one is that you need to know this formula first. Okay, then you know that the 2 to 1 energy is 74.8 electron volt higher than the 3 to 2, so you can create it like this. Okay, by using this formula, so Z equals 3. Third problem, chemistry problem. Okay, I want you to read it by yourself, because chemistry is sometimes a little difficult to be explained. Yeah, so we have, yeah, pi bond here. There you can see pi bond. Okay, yeah, actually the answer is ABD, because C is actually not 3-centered 2-electron bonds. Okay, in its lemuric structure. Okay, this is the 3-center 2-electron bond, not the one that is shown like this. Okay, 3-center 2-electron. Okay, you see 2-electron, but this is not 2-electron bond. Okay, yeah, that's all I think. So yeah, here's a little quote from Albert Einstein. Life is like riding a bicycle. To keep your balance, you must keep moving. That's the end of the video for today. Thanks for watching, thanks for following so far. And here's what you need to do. Please subscribe, give a thumbs up, comment, and share this video to your friend. And also, don't forget to check our website at https://science-with-exploits.uanaux.com, and I'll be back on every Tuesday, so keep watching and be thoughtful. Goodbye, see you.